Hello everyone, welcome to Road to A Plus. So today we're gonna focus on grade 9 mathematics. Uh, so in this stream there are going to be a lot of there are multiple chapters. So without further ado, we will just move on to the first chapter, which is number patterns. I will be sharing my screen and yes. So moving on to the number patterns. So I will be briefing the examples and introductions that they have given, and I will be focusing a lot more in the questions that they have given for you all to do as maybe homework. So because I won't be blabbering much in the sense of the theory which they have given as examples, but when doing the calculations, I will bring out the theory parts which is necessary. So just for a bit of a start, so you can see the part of introduction to number patterns and several number patterns. You see clearly, you can see that in this one, the pattern is just going with 3. Just going with 3, which means that there is no common difference. Okay, there is no common difference. But in this one, you can see between number 2 and 4, there is a difference of 2. And again, between 4 and 6, there's a 2. So here, when you find the common differences, you take any term and you subtract it from the previous term. So here you take 10, you subtract 8, you get 2. From 8 you subtract 6, you get 2. So that is the pattern continues. So if you want to do next two numbers, so you just have to add 2. So just have to add 2 to the next number. So 2, 4, 2, 4, 6, 8, 10, 12, 14, 16, 18. This one again, the common difference is 3, 5, 6, 7, 8, 3, 9, 10, 11, 3, 12, 13, 14, 3, 15, 16, 17, 3, 18, 19, 20 will be the next one, then 21, 22, 23. That's how it goes. Then for the fourth one, it's a bit tricky. So here you can see here, first one, there is no common difference. So what's the number that you add to each number? Is 0. So the addition is 0. That's why the pattern continues as it is. The second one, you add 2. Third one, you add 3. This one, this is a bit of a tricky one. Here, it's a multiple. So here, the multiple is 2. So 2 into 2 is 4. 4 into 2 is 8. 8 into 2 is 60. 60 into 2 is 32. Then 32 into 2 is the next two numbers I will write. 64. 32 into 2 is 64. Then 64 into 2 is 128. Then 128 into 2 is 2, 5, 6. That's how it goes. So this one, this is also a different type. You can see that this was having the same number in like twice. So there are 2 1s, 2 2s, 2 3s, 2 4s, 2 5s. So next pattern is 6 6, then 7 7, then 8 8. That's how it goes. And the sixth one, again something different. You can see this is where to focus on it a lot. So there's 1 1s, there are 2 2s, there are 3 3s, there are 4 4s. The next one is 5 5 5 5 5 5s. Next one is 6 6 6 6 6 6 6. So this is what they have explained up to here. Going down. So that is what they have given the examples, and they've been teaching around that and how the pattern continues. So this is an important part which comes to sequence and pattern. So in this one you can see sequence is the order of the numbers, how it's going to continue to the future. So you can see in the sequence you have number ones, number twos, number threes, number fours, number fives, and number six. And also in this sequence, still you can have number ones, number twos, number threes, number fours, number fives, number six. But even though the total number is the number of numbers in total is equal, this is a separate sequence and this is a separate sequence. It's like ordering it in a specific order, like having the numbers aligned in specific order. You can see in this one it's made in the ascending order. 1 2 ඒ අංකයට වැඩි අංක ටික එක පෝලිමකට යන්නේ. අංක වැඩි වෙන පිළිවෙලට. එකට පස්සේ දෙක, දෙකට පස්සේ තුන, තුනට පස්සේ හතර, පහ, හය. මෙතන එහෙම නැහැ. අංක ටික ඔක්කොම x කරලා තියෙනවා. ඔක්කොම එක එක එකට කලවම් කරලා තියෙනවා. ඒක යන විදිහේ ගැටලුවක් නැහැ. මේ ඒතර සීක්වන්ස් දෙකක්. අංක ගානත් සමානයි, තියෙන අංක ජාතිත් සමානයි, ඒත් හතර තියෙන පිළිවෙල වෙනස්. දැන් අපි තුමු ළමයි පොලිමක් ගත්තොත් අපිට උස පිළිවෙලට ළමයි ටික හදන්න පුළුවන්. ඒ ළමයි ටිකම දැන් ටික මාර කරලා එකම ළමයි කොටස්. ඒ වගේ තමයි මෙතනත්. එතකොට ඒක තමයි සීක්වන්ස් එක කියන්නේ. අපි මොන සීක්වන්ස් එකකටද ඒක මේ කට්ටිය හදන්නේ. අපිට මෙහෙම සීක්වන්ස් එකක් තියෙනවා මෙහෙම. So consists of the same numbers but they have two different sequences. Same numbers, two different sequences. So those are the subtitles which is explained here. Then just like I mentioned, the common difference is 2. You have to write and go. I covered this part. And third question also same, 3 covered this part. Then same questions here covered. So exactly, this is important. Common difference is any term except the first term, because any term and the previous term. The reason that we are not getting the first term is you have no previous term before the first term. So common difference is any term. So if we take its t1 minus t dot, this is just something to remember. You can use it. Just remember the word equation is totally fine. And here this one, there is a common difference. The same so the common difference is 0. Here another sequence. This is a sequence which comes with a negative. Negative means like a descending sequence. Descending sequence. So starting with a higher number, lower it reduces. Still the common difference is same. See, it's -5. Your subtracts. Then comes to other examples, and comes to general term of a number pattern. So when it comes to this is talking about notations. So this is something that you have to remember roughly. So T stands for term. So first term is denoted by T1 because first is T1. Second term is T2. Third term is T3. Then it's got a sequence. We can indicate the terms as follows. So it depends. So now moving on to this example. So second term is T2, third term is another example. So now in this one, this is the first term. This is the second term. This is the third term, the fourth term. So T equals 5, 7, as follows. Then, so this is the theory part which is really important that you have to remember. N is the number of terms, like කීවෙනි එකද කියන එක තමයි n වලින් මේ represent කරන්නේ. එතකොට ඒක අනිවාර්යෙන් මේ it must be a positive integer. Any positive integer that should be a positive. So you can't consider a half term. You can't consider a third 3.5th term and a minus term. Terms is always a positive integer. This is something that you will have to do. Okay, so if it's not a positive integer, it has no meaning. So consider value of n, the corresponding nth term is denoted by t, just like that. So here I said third term is 3, nth term is t4. Just as I said, if it's nth term is tn, then this is an important part that you really have to pay attention. This is from the number sequence when general term is given. So here in this question you can see I'm considering I'm going a bit faster to me that you will have more on this. So in this question there's a term given equals to n plus 3. So write the first 3 terms of the sequence. So first one is you can see, so we have already done it. So first one, what you do is tn is 1 here. This is the first term. Then you substitute. So if it's 1, then here it's going to be 1. Then 2 into 1 is 2. Then plus 3. So is equal to 5. Second one, 3. 2 into 2. So here in the second term you multiply it by 2. N is 2. Then you get 4 plus 3, 7. Okay. Then third term, here 3. Third term, like that. You will have to remember how the pattern goes. So therefore the first 3 terms are 5, 7, 9. So the 20th term is like we have calculated in this part. I would show 20th term T20 equals 2 into 20 plus 3 is 43. Don't forget to put the brackets. It's 43. That's how you get it. Then which term is equal to 123? So this is not 123rd term. This is not the 123rd term. This is the value of some term, and that value is 123. So what we have to find is which term is 123. So what is, yeah, exactly, each term is equal to 123. So we put the equation Tn equals 2n plus 3. Then this total thing is 123. 2n plus 3. Then what we do is 100, and I'm going with a bit of fast calculations, and then n equals 60. You can see that there's sort of other parts you can watch through. I'm just showing you how it is done. Then here, fine, this is a bit important. Find the n plus term in terms of n. So the main equation, I would say, main equation is Ta equals 2n plus 5, right? So what we pretty much do is you substitute n plus 1 in places of n. Then t n plus 1 equals 2 n plus 1 plus 5. So it's 2n plus 2 plus 5 is, sorry, my apologies. In this series, it's 3 here. I'm sorry. So which the actual number is 3 here. So 3, 3, 3. Then 2n plus 5 is the final answer. Then yeah, tn plus 1. I hope you understood that. So pretty much this is same thing. It's another example of the same one. You should be able to find it. Yes, you should be able to calculate. Then moving again. This is the part which is a bit new to you. this is the part which is a bit new. Then show that 18th is not a term of this number pattern. So for that, what we have to do is the equation is Tn equals 56 minus 4n. So for it not to be, if for 18 is not to be a term in this pattern, as if you all remember, when I told you previously, because when I told you previously that it should not be, it should always be a positive integer. The term, it should always be a positive integer. It can't be a fraction, it can't be a decimal, it can't be negative value. So if 18 is not a term, it should be either a fraction, a decimal, or minus 1. If not, if it's positive integer, then 18 is actually a term of this pattern. So what we have to check is 18 equals 56 minus 4n. So if you simplify this, 4n equals 18 minus uh, for n equals 56 minus 18. So what is the value when you subtract 56 minus 18? It's 38 equals 4n. Your n 38 by 4. This 38 can be, is not divisible by 4. Then it's 9.5. N equals 9.5. Oh, here they say 9.5. Same thing. Then so as I mentioned, this is not a whole number. 9.5 is not a whole positive integer. It's not a whole positive integer. Therefore, see, if the term of this number pattern, the element should be whole number. Since it's not a whole number, it is not a whole pattern. I think it's pretty clear. So now we have to complete the table. So this is pretty easy. So what you have to write is like how you get the values. So this is pretty much for the first term. So always I won't do all of them. So you have to, I'll do like a random one. So 50 minus 4 into 1. So don't forget to put the brackets. Okay, I'll do this one as well. 35 minus n. N is 1. That's it. So I'll do one of those which are here. Second term is 3 into 2. Oh, sorry. It's different. It's a different. Yeah. So here it's 5 into 2 minus 1, which is 10 minus 1 is 9. I'll do this one as well. 50 minus 4 into 2 is 4 into 2 is what? 8. 50 minus 8 is 48. Then here the term is good, just so that number 3 should be substituted. Then you should be able to fill all these. Then the general term of a number pattern is, it's given as yes, as this. Write the first 3 terms of this number pattern. So first 3 terms, 4 into 1 minus 3, 4 into 2 minus 3, 4 into 3 minus 3. This is 4 minus 3 is 1, 8 minus 3 is 5, 12 minus 3 is 9. So you can see the common difference is 4 for the 12th term. So T12 equals 4 into 12 minus 3. 12 into 4 is 48 minus 3 is 45. Yes. Then so that 74 is not a number, one of the ones in the number pattern. So 75 is 3, 78, n equals 78 divided by 4, and it is not a perfect division. This will give a fraction or a decimal. Therefore, as it's not a positive integer, 75 is not a term. So here is fraction, so it should be a fraction term. It's not possible for that to happen. Then same questions, everything. It's exactly the same. So you should be able to do it. Here in this is how they teach us to create a general term. In these previous questions that they have given, they give the general term. Now we write or construct a general term. So this is how you find the sequence. So basically, for writing any general term, one of the main things that is important is find the common difference. This is a must. This part will be the one which goes with simple. I'll be explaining that later when we are going down. So consider this sequence as an example: 5, 11, 10, 23, 29. So in this sequence, the first one, that is exactly how they have explained. So the common difference is 6. How do you get 6? 11 minus 5 is 6. So you all know this already. Then how do you get 5 when the common difference is 6? To get a number 5, 6 into 1 is 6, and you subtract 1 is 5. How do you get 11 with respect to 6? Using the number 6, how do you get 11? 6 into 2 is 12, minus 1 is 11. Finding 17 through 6. 6 into 3 is 1. 6 into 3 is 18, minus 1 is 17. That is how the sequence is made. Then that is fun. So this 1, 2, 3 we got is the ones we calculated before the nth term. So for this type of equation, Tn equals 6n minus 1. Simple as that. I know it might look a little confusing, but remember always to get the nth term, and nth term is always attached this number 6. Number 6 is common difference. As I said, common difference is the most important part. Always find the common difference, and it's going to be attached with the simple n. See, that's what they have found. But then let's not a complicated subject. It's you have to find the right theory and the reason behind it. Mathematics is one thing which is only logical. It's very logical. There's a reason that everything happens. So accordingly, if they ask, okay, randomly they have asked, find the 80th term. So just forget this for a second. 80th term. T80 equals, now we know the equation, 6n minus 1. So 6 into 80 minus 1. So it will be 479, just like it's shown. Simple as that. So there's another common sequence, find the common difference, and you will have to find the proper equation. The proper equation respective to that. Then even it's a decreasing like a descending number sequence, still there won't be a problem. It goes in the pretty much the same way. Then let's go to this exercise, which is pretty simple. The difference between the successive terms, we can see. So here they have choose. It doesn't matter which numbers you do take. It doesn't matter common difference. You can take any number and the previous number. So I'm going to take here 31. 31 minus 24. What's the difference? Is 7. Let's take another. Okay, let's take this one. So it's going to be difficult. So 2.5 is what? 2.5. So 4 minus 2.5 is 1.5. So the number whose multiples is used to give a pattern. So exactly, this is what? 7, 1.5. Let's take this one. Okay, let's take 0.5.